Good afternoon. Thank you all for joining. My name is Adriana Underwood. I'm the Director of Communications at PSE Healthy Energy, a nonprofit energy and science research institute based out of Oakland, California. Today, you will be hearing from 3 scientists about the findings of a new study from PSE on the natural gas that is used by 11.5 million California households. The study provides the most comprehensive data to date on the concentrations of hazardous air pollutants in California's distribution level natural gas and the potential for gas leaks to impact air quality. Our website, where you can find a copy of the study, will be shared in the chat. Before we begin, a reminder that participants will be on mute. If you have any questions, please drop them into the Q&A. This call is being recorded and will be posted on our YouTube channel. So with that, I'd like to introduce our panelists. Our first speaker is Dr. Eric Lebel. He will be sharing the key findings with us. Dr. Lebel earned his PhD in environmental earth science and was the lead author of the 2022 study, which found that gas stoves are leaking even when they are off. Next, we will hear additional context about the findings from Dr. Drew Makanowitz. He is a nationally board-certified public health practitioner with a doctorate of public health. Dr. Makanowitz was the lead author on a recent study that found hazardous air pollutants in natural gas throughout the greater Boston area. Finally, we will hear from Dr. Kelsey Bilsback, who will share the health, climate, and policy implications of the study. Dr. Bilsback has a PhD in mechanical engineering. So with that, I'll turn it over to Dr. Eric Lebel.
Thanks, Adrian, for the introduction. Just start this here. All right. So sorry you can't see me today. I'm just cooking my lunch in the background here because it's lunchtime here in California. No, just kidding. We're having some technical difficulties with my computer video, but it is lunchtime, and hopefully everybody's thinking about cooking with their stove at some point. But by now you might have heard about the scientific research that details emissions from gas stoves while they're being used. We know that the gas stoves can emit climate damaging pollutants such as methane, but they can also emit gases such as nitrogen dioxide, carbon monoxide, and other volatile organic compounds while they're in use, many of which have adverse effects on human health. There has also been a lot of scientific reports explaining the climate impacts of burning gas, primarily through carbon dioxide production. But scientists have also warned that we should not discount the methane leaks from the natural gas system due to methane being over 80 times stronger of a greenhouse gas than carbon dioxide. Report after report has come out that shows that gas leaks from all parts of the system. Recently, I led a study while at Stanford where we found that gas stoves themselves can leak natural gas directly into your kitchen, even when they are off. Given that leaks from gas stoves occur at all times of day, we wanted to know what pollution is in gas that can be leaking to people's homes alongside the methane. And Kelsey, the slides are not advancing, so if you can just do it, that'd be great. So now I'll talk a little bit about the findings. What we found is quite notable. We collected samples of gas from 159 households in California and found that every sample contained hazardous air pollutants. These are compounds classified by the EPA to be harmful to human health. Most notably, 12 different hazardous air pollutants were detected in our samples. The most prevalent of these were benzene, toluene, xylenes, and hexane. Of most concern is benzene, which is what we will primarily focus on in the remainder of this presentation. Benzene is a known human carcinogen, of which the World Health Organization states that there is no safe level of exposure. At higher levels, it's also a reproductive toxin and can cause disorders in blood. We wanted to find out if the benzene in leaking gas stoves while off could be a hazard to human health. So to find this out, we performed simulations using the measured concentrations of benzene and the reported emission rates from stoves while they are off. What we found was concerning. Just having a gas stove in your kitchen can create benzene concentrations comparable to the benzene found in secondhand smoke. And this comes from the stoves that have the highest emitting leaks of gas while they're off, and also the highest concentrations of benzene. But any additional amount of benzene leaked into your home from gas appliances is not good. The risk of developing leukemia as a result of benzene exposure goes up when exposed to higher concentrations of benzene. And here we are just modeling emissions from stoves while they are off. When it comes to the reproductive toxin and blood disorder effects, California has set a reference exposure level, below which non-cancerous adverse side effects are not expected. We found that the leakiest stoves, coupled with the highest benzene concentrations, can exceed this level by up to 7 times in indoor air. But that isn't all. Benzene and other chemicals in the gas can have an impact on outdoor air quality too. Based on the levels of benzene in gas that we saw and reported leaks from outdoor infrastructure, we estimate that leaks from gas appliances and the pipes that feed them can emit the same amount of benzene each year in the state of California as 60,000 passenger cars. Many inventories do not currently consider emissions from appliances while off and leaks from gas infrastructure. So these are currently unaccounted for sources of outdoor air pollution. Benzene, along with other volatile organic compounds, can also form smog and ozone outside. Air pollution from ozone is a major problem in many Californian cities. We commonly detected many of these smog-forming gases in natural gas, like ethane, hexane, toluene, ethylbenzene, xylenes, and cyclohexane. Now I'll turn it over to my colleague Drew, who will talk more about our findings in more detail.
Thank you, Eric, and thanks everyone for joining. Let's see if the technical difficulties remain for me. Okay, so determining if gas leaks are hazardous starts by determining what hazards are in natural gas itself. So here is a picture of Eric, who we just heard from, collecting a sample of gas directly from a gas stove. Now, this gas sample gives us information on about 76 different trace gases. We use an EPA standard method with all of our analyses performed by an external EPA certified lab. Now, we sampled all across California, as you can see here on the map on the right. We sampled in 7 different regions or cities, 3 major gas companies, and in total, we collected 159 unique samples from 159 households, as seen as the little black dots on the map. So perhaps not surprisingly, we found pretty significant differences in the results of these samples depending on where the sample was taken. Overall, we found much greater variability by region or city compared to variability by gas company. Now, speaking of variability by geography, we performed a very similar study earlier this year in the greater Boston region. Now, for comparison, the lowest concentrations that we saw here in California are still about 10 times higher than anything that we saw in Boston. This really was a surprising finding, that even some of the lowest levels that we saw in California are still about an order of magnitude higher than the average levels in Boston. Now, some of the highest concentrations that we found in California was also really surprising. The highest benzene level in gas that we found was 66 times higher than the maximum value that we saw in Boston. So it's pretty fair to say that the gas samples that we collected in Boston, for example, are not predictive of gas quality here in California. So some of these higher concentrations that we collected were in the greater Los Angeles area, most notably the Santa Clarita and North San Fernando valleys. Now, we can only really speculate as to the cause of the elevated levels here, but it really is in these areas where we have the greatest concern for impacts to both indoor and outdoor air quality. So let's move back into the kitchen here and walk through how we estimated impacts to indoor air quality using benzene as our contaminant of concern. So as we mentioned, we have measurements of how much benzene is in gas before it is leaked. From previous research that Eric mentioned, also performed in California, we have measurements of stove and oven leakage, particularly leakage while the stove and oven are not in use. We combine both different combinations of benzene and gas and leaking gas rates to model the resulting benzene concentrations in the kitchen space. Now, this is a very simplified description of the model, and there's two other factors that appreciably impact indoor benzene levels, that is ventilation rate and the size of the kitchen. So all told, we modeled various housing types, ventilation rates, benzene leak rates, and simulated 140 different combinations of these factors. So from these results, we found that the highest benzene in gas levels, such as those measured in the greater Los Angeles area, and the highest leaking stoves can result in exceedances of California's reference exposure level for benzene, or a benzene concentration similar to benzene in secondhand smoke. Now, an important point here is that we only model leakage from stoves while they're off. We did not include leakage from pulses, turning the stove on and off, or leakage while the stove is on, which all can be non-trivial amounts. So we know this model is conservative and likely underestimates the actual contribution of kitchen benzene enhancement from the stove appliance. So what does this mean for human health? There are multiple ways to estimate population-level health impacts from environmental stressors. First of all, an increased health risk requires an exposure to something hazardous. Our study, therefore, can be categorized as both a hazard identification study and an exposure assessment study. We measure the presence of hazards in gas and predicted indoor concentrations or exposures using real leakage rates and a well-validated indoor air quality model. We then compared these indoor concentrations to health-based guidelines, such as California's reference exposure limit for benzene, which is about 1 part per billion, a very low concentration, which in part exhibits the high toxicity of benzene. And again, because benzene is a known human carcinogen, exposures are cumulative over the life course. So we really want to try and limit these exposures as much as possible. Now, reference exposure limits are set at a level at which no adverse health effects are anticipated. While exceeding a reference exposure limit does not guarantee an adverse health effect, reference exposure limits rely on the best science available and are motivated to protect the most sensitive groups of the population. So really, this is the first time demonstrating that a gas leak alone in a home can lead to an exceedance of a health-based guidelines as per the state of California. Now, we have been very focused on benzene, but as Eric mentioned, we identified about a dozen other volatile organic compounds in natural gas that when leaked can transform into other harmful pollutants like ozone and particulate matter, which we know are also very health damaging and an ever-present issue facing millions of Californians. So really, this is the first study demonstrating ozone precursors in consumer-grade natural gas in California. And when leaked, which we know is happening a lot, especially in cities, can transform into smog and also is a major ongoing problem for cities throughout California and a lot of other places in the world. So now I'll pass it over to Kelsey to talk a bit more about the broader implications of this work related to public health and related climate policies.
Thanks, Drew. So this graphic depicts the 3 main stages of the gas supply chain. And previous work has shown that natural gas leaks are an unavoidable part of the delivery system. Gas can be leaked during production, processing, and delivery. Methane is the primary component of natural gas and is a potent greenhouse gas that has 80 times the warming power of carbon dioxide. In this graphic here, the methane leaks are depicted as the orange squiggly lines. Our research primarily focused on the delivery portion of the system, but builds on the body of evidence that suggests that hazardous air pollutants are emitted with methane throughout the gas supply chain. And here, the hazardous air pollutants are being shown as the red squiggly lines. As Drew and Eric both mentioned, these hazardous air pollutants have adverse impacts on human health, demonstrating that gas leaks have the potential to impact both climate and public health. So the first conclusion of our study was that gas leaks are a source of air pollution in California that is currently not accounted for in emissions inventories. This means that anywhere natural gas is leaked, hazardous air pollutants are likely being leaked as well. And conversely, this means that if fossil methane leaks are reduced, hazardous air pollutants are likely being reduced as well. Second, through our indoor air quality modeling and outdoor emissions calculations, we found that gas leaks impact indoor and outdoor air quality. This means that individuals, policies, or programs that replace gas appliances with cleaner options can improve indoor air quality. And it's important to highlight that our work on gas appliances looked at the indoor air quality impacts of stoves that are turned off but still leaking. And what this means is that if a gas stove is leaking while not in use, simply opening the windows or turning on a range hood only while the stove is on or being used will not solve this specific air pollution problem. We also know that hazardous air pollutants in the gas delivery system are currently not accounted for in emissions inventories, and that many of the pollutants that we found have the potential to form ozone. Since Californians are exposed to some of the highest ozone pollution levels in the nation, we think that future air quality policies should consider these smog-forming compounds that could be leaked from appliances at the city level or at the state level in California. Third, we found that gas leaks from appliances and systems impact public health in addition to climate. This means that policies or programs that phase out gas appliances to protect climate will likely have public health co-benefits because of their improvements to indoor air quality. We also know that gas is not just leaking from appliances, but that gas leaks are an unavoidable part of the system. This means that reducing fossil methane leaks or moving away from fossil gas systems entirely will likely have public health benefits in addition to climate benefits. And with that, we'd like to thank you for your attention, and I'll pass things back over to our moderator, Adrian, for questions.
Thanks, Kelsey. So if you have questions at this time, please drop them into the Q&A, and we will get some answers from our scientists here. So I can start with a few that we have so far. So the first question is, how closely related or similar is this study to one recently conducted in Massachusetts? Drew, maybe that's a good question for you.
Great. Yes, great question. So very similar. I was the lead author of that study in Boston. So we performed a very similar set of sampling from stoves, sampling for 100% natural gas, and really looking for what else is in natural gas other than methane. One kind of additional piece that we did here in California is we are actually modeling the indoor concentrations of benzene. And so we are taking some previous leakage rates from previous work done in California, as I mentioned, combining that with an air quality model to really try to predict what are the potential indoor air concentrations of benzene just from stoves while they are off, and really just trying to get a better idea of what are the potential exposures here from this exposure pathway.
Great, thank you, Drew. The next question we had focused on basically variations in homes. So this asks specifically about garages, but I think Kelsey, maybe we could talk a little bit about how we did the modeling for different home types.
Yeah, happy to take that. So for our indoor air quality modeling, we looked at a variety of different home types. And so we looked at things like single family homes. We looked at apartment complexes and mobile homes. So the goal here was basically to look at a variety of different ventilation rates, which can in part be driven by the type of home you're living in. And so we use data from the California residential survey to try to inform the sizes of homes that we looked at in our air quality modeling. So we looked at, quite a few different conditions when trying to look at air quality impacts indoors.
Great, thank you. And then how can this problem be solved? There were some questions about, what can we do to address gas leaks in homes?
Yeah, I can take that one. One of the things that we found with our study is that gas leaking from appliances while off, and even in other aspects of the natural gas system, are a rather unavoidable part of owning gas appliances and having gas flowing throughout our cities. So it's not really possible to completely eliminate the source of gas leaking into your homes when your appliance is off, except for if you were to phase out of gas appliances in your house. And in the meantime, what you can do, though, is, especially with gas stoves, is that we also know that there's pollution emitted from gas stoves while you're using it. We know that nitrogen dioxide, carbon monoxide, formaldehyde, those are all pollutants that are emitted from using your gas stove. So in the meantime, what you can do is just make sure that you always use your exhaust hood anytime you're using your stove. It doesn't matter if you're just boiling water or what you're cooking doesn't smell or stink. Just always turn on that gas hood anytime that you have your stove on. You wouldn't bring your propane grill inside and turn it on in your living room without an exhaust hood, for instance. And this is the same thing that's going on in your kitchen. If you don't have an exhaust hood, or if it blows the air back into your kitchen, which a lot of them do, you can see if it does that by putting your hand up by the exhaust hood. And if you feel the air blowing back into the kitchen towards the top of the fan, then it's not blowing the air outside. And then if you have one of those, or if you don't have one at all, you can open a window while you're cooking and put a fan in the window to help increase the ventilation in your kitchen while you're cooking. Yeah, but in the meantime, I think that's the best way to reduce exposure. But as I said before, the only sure way to eliminate leaks of gas while the appliance is off is to phase out of gas appliances. We know that electric appliances won't leak gas into your home because there is no gas to be leaked. So yeah, that's the sure way to avoid this issue.
Great, thank you, Eric.
Oh, also, while we're on the topic, I just want to say one more thing, which is if you ever smell gas in your house, like that's a very different situation. If you smell gas in your house, that means that you have a leak that's probably bigger than most leaks, and one of the ones that we're measuring, and it could possibly be an explosive hazard. So if you ever smell gas in your house, it's important to right away leave your house and call your local gas company. You can find their number on your local gas company's website with a quick Google search. If you can't find the number, then you should call 911. But if you ever smell gas in your house, it could be an explosive hazard, and it's important to leave your house right away. If you ever, but the leaks, I just want to reiterate too that what we're talking about, many of the leaks that we're talking about are not able to be detected by the human nose, but yet they're still there, and they have the same health damaging air pollution associated with them.
Great. Thanks, Eric. So one question we had is, in California, who is responsible for regulating hazardous air pollutant levels in gas, especially VTEX and hexane, and what are the maximum levels allowed? Drew, Eric, would you
Sure.
want? Okay.
I can take that one, yeah. The quick answer is there's not an external regulatory body that sets kind of gas quality standards for natural gas that is delivered. Now, there are some other kind of standards that the industry adheres to, but there are no, like I said, there's no, governmental body that is measuring the levels of these compounds. The gas industry, they do measure the concentrations of some of these compounds at certain points along the gas distribution supply chain. But they are not measuring at the point of end use. They are not measuring at stoves. And so this is really the first study or the second study that is really trying to figure out the concentration of a lot of these healthy emitting air pollutants at the point where we use natural gas.
Great, thank you. And then would these findings be true of other gas appliances?
I can.
Oh yeah, Kelsey, want to go?
Yeah, so I guess there's a couple pieces to that question. The gas composition would likely be similar in other appliances because the gas samples were taken directly from a stove, and it's likely that it would be pretty similar within other gas appliances in the home. But the findings may be different for other gas appliances. The big difference here is that the stove is leaking into your home in the kitchen, while other gas appliances may be vented outside. So it kind of depends on where each gas appliance is located, determining whether it has indoor air quality impacts. But at the thinking about the impacts for outdoor air quality, they're all pretty similar.
Great. And then we had another question that was, why would indoor levels be different in Boston and California if stoves are the same? Eric, do you want to take that?
Yeah, I could take that one. So just to reiterate, so there's two pieces of our study here. So the first piece is what we just collected in this past study, which is the concentrations of benzene and other hazardous air pollutants in unburned gas. And the second component is how much are the gas stoves leaking themselves. And that's the work that I did earlier this year, and found that gas stoves leak most of their gas while they're off, but also leak while you're using them as well. And these the leaks are mostly unburned gas while they're off, and sometimes you can get some unburned gas too while you're using your stove, particularly like when you're turning it on and off. So why would the reason why they'd be different is because of the different benzene concentrations. There's not too much reason to believe that the gas stoves themselves would be much different between California and other parts of the country. The US stove supply is all pretty generally consistent from wherever you go. And all the stoves all act relatively the same. So the amount that the stoves leak are likely more or less dependent on where you are and more on what type of what appliance you have specifically. We didn't find any sort of correlation between age or price of the appliance in our sample size so far, although that's something that we want to look more into as we continue to collect more data. So combining those two things together, the biggest reason why benzene concentrations would change inside your house is because of different benzene levels in the gas itself. The more benzene there is in gas, the higher, the less of a leak you would need in order to achieve the same level as you would in a different setting.
Great, thanks, Eric. So we have another question on, is there a difference between leakage in rental versus owner-occupied homes? And is there income data for area in the LA in particularly high concentrations, in the areas with particularly high concentrations?
Sure, I'll take that one. So as Eric mentioned, we really just don't know kind of the differential leakage factors from home to home. From previous research, it looks like, just about every stove appliance leaks at least a little bit. So it really is, it really, has to do with just the presence of the gas appliance itself. And so I think, just to kind of reiterate, what we looked at basically kitchen size as one of the factors to influence the concentration of benzene in the kitchen. So we really didn't look at, other kind of socioeconomic status factors. This is really just kind of a generic model where we just kind of model a lot of different factors. And so we certainly have additional research to do in trying to really determine what are the actual concentrations in some of these kitchen spaces. So that will certainly be some of our future work.
Great, thank you. And then there was a question about the OEHA RELs. And so the question was, OEHA has 3 RELs for benzene: acute, 8-hour, and chronic. Which did you model?
Yeah, I can take that one real quick. So the 8-hour and chronic RELs are both the same when it comes to benzene for OEHA. It's 3 micrograms per meter cube, which is the same as 0.94 parts per billion. So that was the threshold that we're talking about. And the acute level is about 8 times higher than that. And while we didn't see any concentrations of benzene that got that high just from stoves while they were off, I just want to reiterate also that the benzene exposure is cumulative when it comes to your cancer risk. These OEHA levels are specifically looking at the non-cancer risks, which include the blood disorders and the reproductive toxicity of benzene. But when you look at the cancer risk, the World Health Organization says that there is no safe level. So any extra benzene that you're exposed to in your lifetime is a possible pathway for increasing your risk of developing cancer later in life. And I think what makes our study important is that we're identifying a until now unknown and not talked about pathway of benzene exposure in people's houses where people spend 90% of their time, and just having a gas stove in your house can expose you to a little bit more benzene where you spend most of your life.
Thank you. The next question is, can you speak to the other hazardous air pollutants measured in these samples that the general public might have less knowledge about, and their potential impacts to health?
Sure.
I can take that one real quick. You got it, Drew. Go for it.
Sure. So hazardous air pollutants is a designation that the US EPA has for 187 different air pollutants. Now, all of these are known to cause some kind of serious health effect or reproductive harm. And so in this study, we identified 12 different hazardous air pollutants in unburned natural gas. So Eric mentioned a couple of the other ones other than benzene: toluene, ethylbenzene, xylenes, hexanes. These all have additional health impacts associated with them, direct health impacts associated with them. Also, many of these volatile organic compounds, when they are leaked into the environment, they can transform into other pollutants that we know a lot about that are also harmful, namely being ozone and particulate matter. So anytime there's a gas leak, right, we are seeing hazardous air pollutants, which have a direct health when we breathe them in, and somewhat of an indirect impact on our health as well through the transformation of some of these gases into other types of pollutants.
Okay, thank you, Drew. So we have one question, which was, what might explain the much higher rates of contaminants in the Santa Clarita and North San Fernando Valley? So the regional differences that we saw in pollutant levels. Kelsey, did you want to take this or?
Sure. So we don't have enough information to specifically say what is causing differences in different regions, just that we observe them. We know that hazardous air pollutants are present in natural gas when it's extracted from the ground, and the processing that happens where the gas is extracted from, and many other factors along the supply chain can influence the levels of these contaminants in natural gas.
Great, thank you, Kelsey.
I'll also just take this opportunity to add that even though there were some regions of California that had high levels of benzene in the gas, particularly higher than in other places, that doesn't mean that the other places had low or negligible amounts of benzene. The benzene across the state was all very high, we found benzene and detected in nearly every sample that we measured. And I think that's the fact that there is benzene in gas is, as I just mentioned too earlier, that there is no safe level of benzene exposure when it comes to your cancer risk, that we should be concerned about any benzene in gas, and we did find it in all but one of the samples that we collected in California.
Great, thank you, Eric. So I know we have one attendee who's raising their hand. I'd like to address their question, but also encourage people to put their questions in the Q&A, since we have a lot of people on the webinar. Jacqueline, are we able to unmute?
Yeah, we should be able to. Let's make that happen.
Great. I'll ask one more question and then we'll get to the, oh, there we go. Perfect.
There we go. Go ahead.
Laura, did you have a question?
Yes. Okay, hold on. Can you hear me now?
Yes.
Yeah,
This has been really interesting, and it's obviously an important study. One thing I have not seen or heard is any information on where exactly the gas leakage is coming from vis-a-vis the stoves. In other words, is it the stove manufacturers that are responsible for the benzene exposure? Is it the gas supplier, the investor-owned utility? Like at what point in the transmission does the leakage occur? And maybe you don't know that, but it would be helpful to get a sense of that. Thank you.
Yeah, thanks, Laura. That was a great question. So there's two parts to your question, really. First is where are the leaks coming from, and two, how does the benzene get in the gas when it leaks? So I'll start by answering the where do the leaks come from, which is we know that the gas leaks, at least what we're measuring in your kitchen, we know that they're coming from your stove at some point. We don't know exactly where in the stove they're coming from. When we took all of our measurements, we were in actual participants' homes, and we didn't want to take a wrench to their stove and tear it apart to figure out where the leak was actually coming from in their stove. But we do know it is coming from the stove based on how we measured it. We basically built a chamber around the stove and found and measured the increase in methane concentrations as the gas stove was leaking into your kitchen. So we know that it is coming from there. The best guesses that we have is that there's either it's coming from a misfitting between the gas appliance and the gas supply in your house. If you look behind your stove or underneath it, there's usually a gas pipe, or there is a gas pipe where you can connect your gas stove to. And sometimes that fitting has a leak associated with it. Besides that, sometimes within the stove themselves, we've noticed that sometimes you can notice like gas inside your oven when we stick a detector in the oven, or underneath some of the burner plates. Sometimes you can see a gas leak there as well. So that shows that may be coming from the appliance itself as well. And then we didn't notice any specific trends between manufacturers or price of stoves or age of the stove and the total leaks that we're measuring. We did measure 53 stoves just for leaks, but we did find that nearly every one of them had some level of emissions while they were off. and also while you're using them as well. So that was I think the main take home is that it doesn't necessarily matter, at least what we found so far with the data we have available to us. We're not able to say if there's any sort of trends between manufacturers or type of stove that you have, or but the fact that it is possible for any one of them to do it, and we found that many of them are doing it. Drew or Kelsey, do you want to take the second part where the benzene comes from while it leaks?
Sure, I could take that one. So I think, so this is a methodological question. So we are measuring 100% natural gas. We want to know everything that is in natural gas. This is why we take a sample directly from the stove before it is emitted, before it is leaked. We want to know what 100% gas is made of. So we really want to try to reconstruct that sample or deconstruct that sample and get every single kind of chemical that is in that gas. So, and that's exactly what our sampling methodology does. We get 100% gas, and then we can know all these different chemicals that are in the gas. So then when we measure for a leak, which we use methane as the tracer compound because natural gas is mostly methane, we then can say with pretty good certainty, if we know there is a leak of natural gas, we know that all of these other chemicals that we also measured in gas are also being leaked into, the ambient space or wherever there's a leak. So wherever there is a natural gas leak, everything that we measured for in 100% gas is also being leaked.
Great, thank you, Drew. I think there are a couple questions that are focused on policy solutions. And so there was maybe some granular questions about kind of which agencies have control over this, but I think at a larger level, I'll group some of those questions together and just say kind of what are the policy solutions, related to the findings that you guys found. Maybe Eric, would you like to take that, or?
Sure, I can take that. I can start, and other people can join it and jump in too if they want. The main response to that is what we found is that gas leaks and the pollution associated with them are an unavoidable part of the gas system. We know that gas leaks are ubiquitous, and the benzene concentrations and other hazardous air pollutants in the gas also in nearly every sample that we've taken in this study in California, and also what Drew found in Boston in the previous research. So this shows that the policy that it's not up to the individual necessarily to eliminate these risks, because we know that the gas is everywhere, and it's not. We need to have a good policy that uses the science that's available to make informed decisions on what the right next step forward is. I know that we're all research scientists. We want to just make sure that we present the data that we've collected, and we want individuals and policymakers to make their own decisions based on the science that we have. And what the science is telling us is that the gas leaks are a climate pollutant problem. It's a health pollution problem. And we know that at least when it comes to leaks of gas while the appliance is off, the electric alternatives don't have that problem. There's no gas associated with them, and when you're using them, there's not going to be the same levels of gas that are emitted just from using the appliance, because there's no combustion going on when it comes to a gas appliance.
Okay. Great. So then there was just one clarification. So the question was, please confirm I got this right. The study found more variance by region than gas utility. That seems counterintuitive. So maybe Drew, I'll give this question to you.
Sure. So if you recall the map we were looking at, so there's really only 3 or 4 major gas distribution companies in California, SoCalGas, PG&E, San Diego Gas. And there's a lot of different places in California, a lot of different cities. So when I said more variability by region or city than by gas company, we really do see bigger differences between two different cities, say, than between two different gas companies. And this is also in part because some of the different cities that we sampled in are nested within the same gas company. So there's really only 3 gas companies that we sampled across, and we sampled across 7 different gas companies. So it's in part that we sampled a lot more different cities, and there's really only 3 different gas companies that it can vary across. So hopefully that clears up that question.
Okay, thank you. So then we have a couple different questions that are focused on consumer-based solutions. What individuals can do to lower their risk. And then also if gas detectors are a thing, if there's other solutions that people can do in terms of alarms in their homes and things like that.
I can take that one. So yeah, as we mentioned before, like the best thing you can do if you're an owner of a gas stove is to minimize the exposure of the pollution while you're cooking on your stove. That is something that you can actively do and change today by turning on your gas hood every single time that you use your stove. If you do that, that's great. That's the best thing you can do. If you don't do that, start doing that today. Every time that you cook, doesn't matter what you're cooking, turn on your range hood or open a window or both if it's a nice day outside. Then when it comes to the gas detectors, so I did look this up. We went to checked our local hardware store, and they make these gas detectors. They're usually coupled with carbon monoxide alarms, but they also claim they can detect natural gas. I've never actually plugged one into my house because I don't have a gas stove. But I did read the instruction manual, and it looks like that these detectors are designed to detect high concentrations of gas when it's on the verge of becoming an explosive hazard. So these are very useful, especially if you don't trust your nose, or if you know that you have anosmia or you can't really smell things very well. It's a great way to have a external validation if you have a dangerously high explosive leak inside your house. But it won't detect many of the leaks which we're talking about here, which are those lower level leaks, which are below the explosive hazard. It's not an explosive hazard, but we do know that natural gas is leaking into your home, or can be leaking into your home through the gas appliances, gas infrastructure, the pipes that bring the gas throughout your house. And these levels of gas and the associated benzene with it will not be or may still be damaging to your health, but won't be high enough to set off this alarm. So it's not going to detect all the leaks, but it will detect the highest ones.
Great, thank you. So there are questions, I think, just a little bit more clarity on kind of where and when and how ubiquitous the chemicals that we found are in the gas. So if maybe someone could just speak a little bit more about what we tested for and where you might expect to see, what we found in gas throughout California.
Was that for me?
I didn't assign it, but Drew, if you want to take it, that'd be great.
So sorry, can you repeat the question, Adrian?
Yeah, I think there's just a couple questions that are getting a little bit more like asking for a little more clarity on what we tested for in the gas itself, and then if this is what they would expect to see, throughout the distribution supply chain, kind of what we understand about what is in gas based on what we found.
Sure. So when we collect a sample of gas, we really were targeting a certain kind of subset of pollutants or contaminants. And these are all kind of hydrocarbons, which basically they have carbon and hydrogen bonds. And so some of those, as we have mentioned today, are hazardous to our health when we breathe them in. And so what we do know about these class of chemicals is that some of them are naturally occurring in underground formations. I think Kelsey mentioned this before. And so, if you've ever seen kind of the health literature around health impacts to living in proximity to extractive industries, there's really now a pretty rich literature on the health effects associated with living near extractive industries. One of the hypothesized exposure pathways is through air pollution exposures from pulling hydrocarbons, oil and gas out of the ground. And one of those suites of pollutants are the same pollutants that we're looking at here in our study when we collect a sample from a stove. So we know that these volatile organic compounds are throughout, I mean, they're entrained in natural gas from the start. And then it really is the degree to which they are processed out, the degree to which other kind of external factors impact whether they're in gas phase or liquid phase, pressure and temperature matter, all different kind of processing matters. So what we do know is a lot of these pollutants that we're interested in, they are present in the underground formation when gas is extracted out of the ground. And so really we were trying to figure out the degree to which those pollutants stay in natural gas. So the fact that we are finding them at the point where we use gas is, pretty much confirming that all throughout the rest of the upstream portion of the supply chain, they're all there as well. So again, anytime gas is leaked, doesn't matter if it's your stove, your hot water tank, a pipe in the street, further upstream, we really are going to see this similar kind of suite of pollutants.
Thank you, Drew. So then we have another couple of questions that are curious about, what else leaks. So we're, in this study, we're looking only at the leaks from gas stoves while they are off. But this is asking, there are a couple different questions that are wondering, do stoves or other appliances leak, such as dryers, right? And I know Kelsey touched on this a little bit before. There's also questions around kind of, restaurants and other places of leaks. So I wanted to just bring this up again because we have a couple different questions on this one. Eric, maybe this is a good one for you.
Sure. We do know that other appliances leak as well. There's been lots of other research on this. I've led a paper looking at water heaters and found a similar thing, that they can leak even while they're off, while they're turning on and off, while you're using them. And other appliances have, other studies have found similar conclusions for other appliances as well. I will just note that a lot of these other appliances are not directly in your house, right? You don't necessarily have your furnace or your water heater like in the middle of your living room. Some people do, but a lot of times they'll be either outside or in your garage or in a basement. And so the risk of the gas leaking directly into your home from these other appliances is not as high as with the gas stove. However, we know that there's also gas pipes within your house that can bring the gas from the meter to the appliances, and they all have potential for leakage as well, and that gas can easily make it into your house. I will also just say too that the gas will eventually make it outside, no matter if it's leaked inside or directly outside. And as we mentioned before too, this also has the impact on outdoor air quality, particularly in California. We know that there's a lot of ozone attainment issues in a lot of major cities in California, and gas leaks are not something that have been widely considered as having an implication on ozone and air quality in cities. So I think it's important to also consider that gas leaks themselves can be a source of ozone precursors and degradation of outdoor air quality as well. And then there was a bit of the question about commercial kitchens too, which I think is a really important topic and something that we're definitely would like to see happen in the future. And we didn't measure emission rates from commercial kitchens at this time, but we do know that they use the same gas as we've measured in the cities here. The commercial kitchen stoves will have are buying their gas from the city distribution lines, and the concentrations of benzene and other hazardous air pollutants will be similar to what we found in other places, like in the local area. So it's something else would like to, we don't want to say to commercial chefs what to do, but to know that this is definitely something that maybe has not been considered yet. That's another exposure pathway for benzene in your kitchen, and it could be an occupational hazard as well.
Thank you, Eric. I also think we had another question here that says, what is the threshold for reproductive toxicity for constant exposure? I don't know if that's something that one of you feel comfortable answering.
I don't know the answer to that
Okay.
question offhand.
Okay. Well, with that, I think that's the end of the questions that we have in the Q&A. So I will go ahead and just remind people that I know we got one question that was, of asking about the slides, and we are going to be sharing the slides. Those will be available to all participants on our website. I'll be emailing those out along with a recording of today's webinar, which will also be posted on our YouTube channel. So thank you so much to our panelists, to scientists, for sharing their findings, and thank you to everyone who joined and for your questions. We really appreciate your interest in the study. And yeah, I will be sharing out the resources after this webinar. So thank you all so much, and have a very nice day.
Thank you, everybody.